Hey, what's up guys? So, it's been a little bit. I know there was a 2-week break between these videos. I was trying to get one out every week, but my editing program kind of screwed up the last video I was trying to put out, so couldn't get that out in time. And I'm going on vacation soon, so I'm trying to record all of these videos before heading out. Hopefully I can get them all uploaded in time. And hopefully there's at least 3 gonna be released on time until I have to record some more. So this video today is about the different network architectures that are covered in the ICND1 exam. And there's really only 2 of them that we're going to talk about. And the first one's going to be the 3-tier. And the second one is going to be called the collapsed core. Now these are both more or less logical topologies. They're not a physical layout of the equipment. And they're designed mostly for redundancy, but also for easily separating roles and security areas, and also for scalability. So this architecture can easily be added to or taken away from. It's kind of structured. It's not just placing network devices here, there, and everywhere with no real plan. So these 2 options, one of them, I'll just go ahead and say this first one, the 3-tier, is going to be for your large networks. We're talking thousands to tens of thousands to hundreds of thousands of users. And then your collapsed core is for your medium to small. And these are the 2 architectures that Cisco puts out there as a best practice and a good way to organize your network. So first we're going to talk about the 3-tier architecture. And you may have already seen this either in a book somewhere with examples thrown in, or if you've ever looked at a lab, or maybe you've just come across this topic already and kind of wondered what it was. But here is the design of it. So you've got your core layer at the top, which we're only going to draw out 2 of each. So those 2 are the core. These 2 are going to be your distribution layer. And then you have your access layer at the bottom. And they'll be cabled up something like this. Every access switch will have one connection to each distribution switch. Typically your distribution switches will have a connection between them, typically a multi-link connection, ether channel, port channel, whatever you want to call that. And they'll have redundant connections to the core layer as well. And your core will have its own connections in between each other. So those are your 3 layers for your 3-tier network architecture. So the access layer down here is where all of your users are going to be, all of your whatever clients, desktops, phones, everything needing access to your network. I mean, your access points, we talked about those in the last video. And typically the devices you're going to use here are going to be high port density, but not really feature rich. You can usually get away with just regular layer 2 switches, just real, well, cheap is a relative term, but cheaper stuff. The only real requirement is that you have enough connections for the amount of users you want. So you'll usually see a like a 3560, 3750s. I'm not really sure if those are still around, but I think the 3850 is the new standard access layer switch. And it'll depend on how many users you are wanting to connect up. So you can have either just one switch, 24 or 48 port. You could have a switch stack, like multiple 3 or 4 regular 1-unit switches stacked together. Or if you have a lot of users, I've even seen some of the what were they? Was it the 6500 switches, the chassis switch with multiple cards in it. Just all depends on, for one, what kind of features you need at the access layer, and 2, and your most important, is how many users you're going to be connecting. And typically, this access layer is a building, or you might have, if it's a small building, 1 access switch for that building, or you could have multiple access switches all over the building, or just 1 core area with a massive switch if it's a large building. If you're thinking of an office building, it would probably be 1 switch per floor. Now the distribution layer, this is where all of your access switches go to. So this is where the redundancy comes from, really, because each access switch will have one connection to each distribution switch. So if something happens to, say, this link here, these users will still have access through your second distribution switch. And at this level is where all of your services and security and all that are going to be set up. So like your access control lists, if you're connecting to the WAN, you'll be doing NAT here. Your firewalls will probably be set up here in the distribution layer. And if you're redistributing between routing protocols, then that's probably going to happen at your distribution layer. Distribution, its number one role is to aggregate all the access switches, and its second role is to do all of the security and all the services that you need down at the access layer. And the reason for that is because your core layer is supposed to be your quickest layer. The only job really of your core layer is to move traffic as fast as possible within the core to different parts of your network. You won't be using ACLs or doing NAT or any of that because it takes processing power, and processing power is very important in the core because it's going to be dealing with a massive amount of traffic, and you don't want that massive amount of traffic being process switched through the CPU when there is that much traffic, so you won't be applying your ACLs there. Your distribution switches should be robust enough to handle that kind of a workload. Now, another thing you'll typically see at the distribution layer is your switch virtual interfaces. These are usually going to be the default gateway for all of your access layer switches. And what that means is that you're going to be running layer 2 or just regular switch ports and trunks from here down. And typically from here up, you're going to be running layer 3 or routing. So you're going to have a layer of separation here between your broadcast domains, which should be just a single switch, single access switch, and then you're routing everywhere else in your network between distribution and the core. And usually the reason for this is because you don't want to spend the extra money, or you just don't want to design it this way. But layer 3 switches are more expensive than layer 2, so typically you put only layer 2 switches at your access layer. Now there is something called layer 3 to the access layer, where all of your switch virtual interfaces and all of your layer 2 stuff happens only in your access layer area, and then you have routing from the access layer up. But that's kind of a different design thing that's sometimes preferable, sometimes it's not. Now the other thing I was going to say about the distribution layer, this is typically where you'll see HSRP running. If you don't know what HSRP is, it stands for Hot Standby Router. It's either router or routing protocol, I forget, but it's a redundancy protocol. So you can have the default gateways for, say, this access switch for a certain VLAN would be on this distribution switch as, say, interface VLAN 10. And you can run a standby group between distribution switch 1 and 2, where if this one were to fail, distribution switch 2 would automatically take over as the default gateway for VLAN 10. And that way, if your distribution layer switch just completely fails, then your access layer switch still has a default gateway, and all your clients do as well. And I know I haven't made it far enough into this video series to really explain default gateways and IP addresses and all that, but each client needs a default gateway, and your default gateway needs an IP address, and you can't have duplicate IP addresses in the same network. So if you had a default gateway switch, a default gateway IP set on distribution 1, if distribution 1 went down, your clients wouldn't know where to send traffic. So even if you had a connection through distribution switch 2, your clients wouldn't fail over to it because they have a specific default gateway set. And even if you had a different DHCP server running, you'd have to wait until your lease timed out to grab the new default gateway. And that's what HSRP does, is it allows for basically the same IP address to run in two different places in your network and automatically fail over between the two. I'm not sure if I'll be going over HSRP in this series or not, but if we do, you'll learn all about that. That's definitely a cool protocol. Alright, so what else happens at the distribution layer? Well, I guess I could say what type of equipment's usually here. This is typically your 6500 series, like your 65, I think they're 05s, the big switches with multiple cards in them. Now, if you're in a smaller network and you don't really need a ton of processing power, or you don't have that many access layer switches, you could get away with a regular layer 3 switch here, like a 3850 or 3750. If you're running a small network and don't have that much, you can get away with one of those. But typically you'll see your massive switches here. The 6500 series is mainly what I see in the distribution layer. And I've already touched on the core layer, but going up to there, typically you don't want to have any process switch traffic up here. You want all of your power dedicated to just moving traffic as fast as possible. And like I said, your core layer is going to be there when you have tens of thousands of users in your network. And the type of equipment you'll see in the core, typically, I think Cisco says it's their 12,000 series internet router. I've never seen one of those in person, but I have seen people get away with running 70, I think they're 7600 series as a core router. Either that, or mostly what I see in my experience as core routers are actually Junipers. I haven't actually seen a true Cisco core router being used. Where I work, they use Juniper in the core, probably because of the cost difference. And I'm actually going to give an example of that later, kind of how I've seen this type of architecture set up. But before that, I'm going to move on to the collapsed core design. And it's actually really simple, if you know this one. Alright, so got rid of all my stray markings there. So now it's time to draw the collapsed core architecture. And all we got to do from here is just delete the core out. So if you didn't guess from the name, collapsed core actually means there is no separate core. You run your core services, or you basically do the same job as the core in your distribution layer. And it's called collapsed core, but essentially you're just running without a core. And this is why it's for smaller networks who don't really need a core. You don't have to have a complete separate layer in your architecture to run core services and route fast between your different nodes. Yeah, if you don't have that many users, you can definitely get away with just using your distribution switches for this. And you can kind of, I guess, mirror it on the other side if you want to look at it kind of like that. So you've got these 4 switches and they're all distribution, and then these have their redundant connections out to your other access layer switches on the other side. And then you've just got all of your redundant connections between your distribution switches. That's really all there is different between the 3-tier and the collapsed core. You're just getting rid of that core layer and running everything you need on your distribution layer switches. And this is probably the most common that you'll work with, unless you're working for a very large company. I'm always dealing with collapsed core designs. In our networks that I work on, there's no real need for a core. Although I did say that I would show you an example of the core, but you'll kind of see that it's a little bit weird of an example because it doesn't follow this architecture all the way up. The core is actually kind of it's like an ISP network mashing together with a local enterprise network. So it's kind of 2 different architectures mashed together. Another note about the collapsed core is sometimes with this, if you're kind of getting on that edge where you're a little larger, you might want a core, but you don't really have it yet. Another option that you could do is kind of offload some of that processing down to the access layer and do what I mentioned earlier and do layer 3 at the access layer. So you would make these routed ports instead of switch ports. And then you can run your ACLs and all of that kind of stuff down at your access layer without having to use the processing power of your distribution switches, because now they're pulling double time. And I'm not sure if Cisco really goes into layer 3 at the access layer anywhere on any exam, but if you hear that, just know that you're running routing on your access layer switches and layer 3 all the way through your network, basically. Typically when we talk about this 3-tier network design and the collapsed core, it's assumed that it's layer 2 from the distribution down and that you're running your virtual interfaces on your distribution equipment. So just a few final things. Your access control is done at your access layer. So like your port security, .1x if you're running that. Your pretty much almost, I don't want to say physical security. Well, your physical security is definitely at the access layer, but your more port-based security is done on your access switches, because that's where people are plugging in at. That's also where you're going to protect against switching loops, broadcast storms, by using your BPDU guard. That's what I'm thinking of. So you can guard against broadcast storms in your access layer. But you have to differentiate that type of access control from your filtering, which is going to be done typically at your distribution layer using a layer 3 access control list. Another kind of common question that I hear a lot is, how do you determine where to use VLANs or what to segregate with a VLAN? And I realized that I haven't talked about VLANs at all, but a VLAN is just a virtual LAN, and it separates broadcast domains. Typically, you would use one VLAN per service per building is what I've seen the most of. So usually you'd have your client connections, your client data, desktop PC connections in one VLAN for one building. And then you'd have all of your phones in another VLAN for that building, and probably like printers in yet another VLAN for that building. What you don't want is the same VLAN spanning multiple buildings. So say like VLAN 10, you don't want it here and here. You want to keep your VLANs separate and at around the per building level. Now obviously you're going to use more than one VLAN if you have like a massive building. I'm just talking about a normal size like office building, not multiple floors. If you're running, or if you're putting a network in like a multiple floor actual high-rise office building, you're probably going to use one VLAN per floor or one VLAN per section. And also it's going to depend on what you're making the network for. The example Cisco gives a lot is like accounting versus HR versus management, administration. They would all be in their separate VLANs so they can't access each other's resources. I mean, that's kind of true, but typically in an enterprise environment, the resources that you have access to is probably going to be controlled by Active Directory or something like that. You're not going to really cut off people in your same organization from the network with access control lists. You're going to probably have Active Directory policies and all that kind of stuff to control what resources they have access to. Now, if you're setting up a network for like a mall where they're all actual separate companies and you're not all one organization, then hell yeah, you're going to probably separate them with an access list at the distribution layer. That's just kind of something I don't really get asked, but I hear people ask it all the time. Like, I don't know where to actually assign VLANs in the real world. When you actually get there, it kind of makes some sense how you do it. Another note is that even though the distribution layer, it's said that it usually runs NAT, ACLs, and all of that kind of filtering and process kind of stuff, what I've typically seen in the real world is you'll have your distribution layer routing between all of your different buildings and all that, but your actual edge is going to be a separate device that's going to be running Okay, so I kind of messed up there. I had the eraser selected, but what was I saying? Even though it said that the distribution layer runs NAT and ACLs and all that, typically in the real world I've seen a separate device or a separate stack of devices running your actual NAT and ACLs to the WAN. So just be aware, while Cisco says the distribution layer usually connects directly to the WAN and runs NAT and all that right here or between them, typically you've got a separate device, which is usually an edge router with your NAT and all that capabilities to the actual internet, which I guess would technically still be in the distribution layer since it's connected up here, but it's not really tied into your whole distribution system. Okay, so the last thing I'm going to talk about, and I don't know, I think I said the last thing I was going to talk about was like probably 10 minutes ago, But last thing I'll mention is just kind of the example of how I've seen these set up in the real world, like an actual almost real drawing here. And I'm actually pretty surprised that the places that I've worked at do follow these design types. So just one example, let's say we have two separate campus areas. We'll just say campus east and campus west. And these will be like an entire city apart, probably, I don't know, 15, 20 miles apart. So over on the east, you're going to have all of your different buildings. And each building will have one or multiple switches in them. And we'd have two distribution switches set up somewhere in another building on the campus. And we would run layer 2 all between here. We didn't have layer 3 to the access layer. One other thing to mention is that the buildings that these distribution layer switches were in actually would use a card for access. So this isn't actually a physical device. We had all of the clients in the building that had a distribution layer switch just connected straight into the distribution layer. And that is something that you kind of need to be aware of, is that with this design, it's a logical topology. So it's not saying, I know I said that at the beginning, these aren't physical pieces of equipment. You can have the access layer on a distribution device. That's just how it's logically separated. So we would have all of our clients in that same building off the distribution layer switches. And then we had some leased fiber or leased lines between our two campuses connecting our distribution layer switches. So we had 4 of them, and we did have the line between distribution layer switches. And each of these were physically diverse. That's what I'm trying to say. And then over here you'd have the exact same setup mirrored with the different buildings and the access layer switches connected to the distribution layer. So that is how I've seen it done in quite a few different places. And then to get to the WAN, we had our like edge devices over here. I think we actually had 2 different ones connected into the WAN. Whoop, that just got really sloppy. But just for visual reference, that's what I've worked on. That's how I've seen it done. Now the core part that I was kind of mentioning earlier is pretty much beyond these WAN edge devices over here, and it's basically a service provider network, which I'm not going to draw a service provider network for you, but we would have our edge devices connected into what's called the service provider edge. And actually I think they were all on one side because only one campus had a connection to the WAN. So it would be over here, and then this is the service provider edge, and then that thing had redundant connections to 2 core routers in the service provider cloud, which we actually serviced as well. And these were those Juniper things that I was talking about. And then between all of these Juniper core routers, you had redundant connections to other core routers. And then eventually on another side, we would have another campus drop off. And these service provider edge routers, which are still technically core routers, but in the service provider network, they're kind of like a distribution switch, even though they're not switching at all. These would service multiple campuses. So all of these things that you see, all of these big networks with the multiple buildings and the distribution layer switches, those would all aggregate to one router. That is what we would call as like the core. And then those went up into more core routers, which were redundantly connected to other cores so that they could come out at another campus somewhere else. I know that was probably a terrible picture of the core, but that's how I've seen it done. There's a ton of redundancy in your core, and you are running high-end equipment. These Juniper routers I've seen, each card in them with probably 4 interfaces, each card is over $100,000. That's how robust you're getting when you're talking core equipment. So I might have gone off topic just a little bit in this video, but Mainly, what you need to know is what happens at each layer of the three-tier network design. And really all you need to know about what happens is core layer, fast as hell, no filtering. Distribution layer, NAT, filtering, security, aggregating your access switches. And then access layer, user connections. And your low-level access control like port security on there. It's about all you need to know. And then just know that collapsed core means you're getting rid of your physically separate core layer and putting all of that load down into your distribution layer. So hopefully I threw in some extra stuff that you didn't already know, and hopefully you learned something new, and have a good time networking.